Paper consumption at CSUN. Problem. During the academic school year, attending students and faculty on campus are raising carbon emissions in the atmosphere due to paper consumption. This is contributing to global warming. Why care about paper consumption? Paper itself is not a negative source given it is made of fibers from a plant, most commonly a tree, and can be broken down by natural processes. Even though the material itself is sustainable, the methods in which we manufacture them are not. To get a better understanding, we need to look at most of the industry. American Forest and Paper Association. Who are they? The AF&PA represents more than 3/4 of the pulp and paper sector in the United States. They not only make paper products, but also produce building materials related to wood. According to the AF&PA, paper has 5 stages in its life. It begins by harvesting raw material, it then goes through production, then to manufacturing, to the consumer, and finally it reaches the end of its life. Once at the end, it will be discarded or recycled back into the system. In the AF&PA Life Cycle Assessment Summary Report, the 2 biggest sources of carbon emissions are from the production phase, 58.3%, and the end of life phase, 36.7%. These emissions can be attributed to the power necessary to produce these products. Disclaimer: the Life Cycle Assessment Summary Report was published in 2007 and was republished in 2010 by a third party. Any concurrent reports are controlled by the third party and does not allow anyone outside of its institution to readily view them. The intention of this data is to show a percentage which should remain relatively stable over the years. California power. These forms of power can vary depending on the resource availability. Here in California, most power is produced from natural gas. We have 4 different graphs. This is just a still shot from the original graphs. If you want to see the original dynamic graphs, click on the link below. In the top left box, we can see that we have California selected. The next graph shows us what fuel source is being consumed and how much carbon dioxide is being emitted. The most common measurement for carbon dioxide is 1,000,000 metric tons. This graph in the bottom right corner is the sector emissions. You can't see it, but the sector highlighted is the electrical sector. The last graph on the bottom left is the total amount of carbon dioxide produced by the electrical sector beginning in the 80s. From these 4 charts, we can safely say that California is emitting carbon dioxide to meet electrical demands. Our needs to produce power via fossil fuels have gone down, but it isn't enough. We will cover this again after going over our NASA slide. So the issue here isn't the paper itself, but the carbon emissions that go along with it. The next logical thought process would be to question if carbon emissions are harmful or not. In order to do so, we will evaluate data provided by the National Aeronautics and Space Administration, NASA, the Environmental Protection Agency, EPA, the National Oceanic and Atmospheric Administration, NOAA, and the National Snow and Ice Data Center, NSIDC. Following that, we will look at legislation from California, the United Nations, and lastly, our own institution, California State University, Northridge. National Aeronautics and Space Administration, NASA. Now that we have established paper manufacturing is responsible for partly contributing carbon emissions, we will establish their impact on the environment. NASA utilizes satellites to monitor carbon dioxide in our atmosphere. The most current instrument is the Orbiting Carbon Observatory 3 that was launched in 2019. According to NASA's findings, carbon dioxide remains in the atmosphere for a minimum of 300 years and a maximum of 1,000 years. The Orbiting Carbon Observatory 3 functions by measuring reflected sunlight off the Earth and measuring the different wavelengths. Each wavelength corresponds to a different compound in the atmosphere. This allows NASA to isolate carbon dioxide. The benefit of this instrumentation is to see the day-to-day differences in the atmosphere to help identify the dynamics of carbon dioxide. Currently, annual data is collected and consolidated, but they lack the day-to-day fluctuations. The short GIF on the right is a visual representation of the annual data. It begins during the 80s and continues to 2018. Here we can see that we start off mostly blue, but as time goes on, orange and red are now the predominant colors. This is where things begin to get interesting. Our previous slide was showing a decline in emissions, nearing our original start point of about 35 million metric tons. Logically, that graph would indicate the mean temperatures should be going back down if carbon dioxide warms the planet. This GIF challenges that logic. Reducing emissions and expecting an immediate result isn't feasible. Remember, according to NASA, carbon dioxide can remain in the atmosphere for 300 to 1,000 years. A limiting factor here is we aren't including how much the Earth can reclaim through natural processes. With more time and research, the Orbiting Carbon Observatory 3 can help us determine the variable and give a better estimation of our actions. Environmental Protection Agency, the EPA. This graph here was formulated from carbon dioxide emissions listed on the EPA site. The original data was broken down by individual states and the 6 respective sectors. The 6 sectors are residential, commercial, industrial, transportation, electrical, and fuel totals. As the title suggests, we are looking at all the United States carbon emissions, starting from the early 90s. Just as our electrical sector dashboard showed us, we started off in the green, peaked in the early 2000s, and dropped back down as we get closer to present day. Do not let the green on the chart fool you. Just because it's green doesn't mean it's a safe amount. Just because we are beginning to see less emissions, it doesn't always mean we have solved the issue. In 2018, the EPA reported that the pulp and paper sector as a whole emitted 25,720,159 million metric tons of carbon dioxide. In 2017, 18,350,000 tons of paper were sent to the landfill. This landfill statistic is demonstrating that paper cannot be infinitely recycled. At some point, it reaches a landfill. National Oceanic and Atmospheric Administration, NOAA. The first graphic here on the left shows a small visual representation of the graph in the middle. The index here is a light blue, least concentrated, ranging to solid white, most concentrated. At the beginning, we can see most of the polar north is covered in white. As the months progress, we see the white diminishing drastically. The yellow line indicates the previous month's boundary. The graph here in the middle is the numerical representation. This graph covers a wide range, unlike the GIF. Here you see all these blue columns that correlate to each year, from 1980 to 2020. The height of the columns are distinguishing area, kilometers squared. The red line going through the graph is the trend, indicating a decrease in ice mass by 2.59%. The last chart we have here has several things going on. The gray line is going to be your sea level. Now your purple line is your blue line and your red line combined. These blue lines from snow and ice melt. The red line is the meltwater expanding as it heats. When you combine these two, it becomes an extension of the gray line, ultimately increasing sea level. Since the beginning of this graph, the sea level has rose about 8 to 9 inches. Thus far, we have seen carbon dioxide has been continually pumped into the atmosphere, causing global temperatures to rise. As the atmosphere begins to warm, a vast majority of polar ice and snow begin to melt, causing sea level to rise. Our ecosystems are complex and can be resilient, but we have given it no time to adapt. We have begun a rapid process of change. Many regions now have modified precipitation patterns, affecting accessibility to water. To compound that, agriculture is now affected, increasing the chance of food shortages. A warmer climate also puts a thermal stress on us and increases disease from a multitude of sources. National Snow and Ice Data Center. Here we have 2 charts. Before we get into the specifics, I want to let you know that this is old data from 2007. These charts aren't used to portray specific numbers. The intent is to show a cause and effect. The one on the left is showing 3 different sections: small glaciers and ice caps, Greenland ice sheet, and Antarctic ice sheet. The gray bars refer to size, and the red bar shows how much it contributes to sea level rise. This is just a further look into how the polar ice and snow are melting. Smallest masses melt first. The second chart, the one on the right, shows us the correlation between global temperature and the sea level. The blue line indicates increasing temperature. The red line is showing an increase of sea level. It is evident that the temperature and the sea level have a direct relationship with each other, echoing what NASA and NOAA data portray. Now let's turn our attention to legislation. California. California has recognized climate change is a real threat. The state has pledged to target 7 gases that are having a warming effect on the atmosphere. Among the 7 named, carbon dioxide is at the top of the list. The goal here, according to the Assembly Bill 32, is to reduce greenhouse gases while maintaining our economy. The specifics of the bill is to reduce its greenhouse gas emissions to 1990 levels by 2020. United Nations. On September 23, 2019, the United Nations held a Climate Action Summit. 75 countries attended, with 90% of them committing to implement more stringent environmental plans for their country. The ultimate goal of the United Nations is to reach net zero emissions by 2050. Now our own university. CSUN. CSUN formulated a climate action plan in 2016. In the university's plan for sustainability, they addressed one of the chief causes towards climate change is the increasing amounts of carbon dioxide. Section 1.2 of the plan reiterates the trends of climate change highlighted by NASA, the EPA, NOAA, and the NSIDC. Increasing temperatures, melting polar ice and snow, along with rising sea levels, pushed the university to adopt California's AB 32 law and best the United Nations goal of net zero by 10 years. Being that we have identified and validated that carbon emissions are changing our planet in a negative fashion, what are we going to do about it? How can we reduce CSUN's carbon footprint? We can reduce the amount of paper being used on campus. Here is my proposed solution. 1. Transfer the printing requirement to the student. 2. Ensure that Canvas is being utilized fully to turn in and distribute course material. 3. Remove free printing at the USU. 4. Incentivize students by giving them remainder of print amount. And 5. Partner with Microsoft and/or Apple to lower cost of tablets to aid in a paperless campus. Before moving forward, I'd like to give a little background as to why I chose a problem and the logic behind the solution given. At the beginning of every semester, I will most likely have a duplicate syllabus. How does this occur? The professor will upload the document to Canvas or email it out for our viewing. Trying to be a good student, I print it out and bring it to class. Upon the start of the class, the instructor is passing out the same syllabus. Do I not take the syllabus and let the instructor dispose of it, or do I take it and dispose of it? If this happened to me multiple times, I'm sure that has happened to other students. I sent out an email to about 20 departments to ask them about their procedures regarding their paper utilization. I got 8 responses back, and for the most part, there is a lack of consistency. Some departments had no limit on paper usage, and other ones that do have allotments, they are controlled by username and password. One department determined its printing cap by averaging out previous year expenditures. The first step in my proposed solution removes the syllabus scenario from happening. If we can get instructors to not print on behalf of the student, the university can get a true representation of the student's need for paper. By adapting this model, we are letting the market decide the demand. Step 2 is necessary to ensure Step 1 succeeds, given this is where students should be looking at additional course material. It seems that it would benefit the university if the students and faculty fully utilize a service that it is paying for. Step 3 is counterproductive to CSUN's sustainability goal in purchases and consumption along with general operating expenses. Currently, every student gets $10 every semester to print. If a student prints in black and white, they should be able to print approximately 142 sheets per semester. If one manages to use all their funds for the semester, they can always add a balance to their account next to the printers. By offering free printing at the USU, the university is undermining its own system of regulation. Step 4 is there only after a true representation of paper needs are established. As a student who has an iPad and a laptop, I find myself rarely printing. A student that prints more often because they don't have that same technology might be inclined not to if incentivized. In order to incentivize, I suggest giving the student the remainder balance of their printer funds. This should make the individual think about the next print a little harder, given they're the ones that can lose out. Step 5 would be the pinnacle in paper reduction, because a tablet can do way more than a sheet of paper. The tablet can help the student utilize Canvas more, give them accessibility to utilize the free 365 suite, and when a tablet is paired with a smart stylus, it can replace almost every stationary item that is associated with paper, which can have its own environmental benefits. Not only will a tablet reduce the need to print, but with more and more textbooks being offered digitally, you can reduce the cost of education for the student. Now let's talk feasibility. Step 1 through 3 should be extremely feasible. The implementation is just establishing new ground rules for faculty. Step 4 is where we begin to see a difficulty in feasibility. In order to take the funds from the student's account and charge it back to them requires a digital infrastructure and the political agreements within the university. The last step is the most unfeasible because of the complexity. For this to happen, Microsoft and/or Apple would have to agree to take a financial loss upfront to increase accessibility to their product. Not only would the company need to take a loss, you would most likely have to draft a contract to ensure proper execution of the intended outcome. There is a high probability that there is already some sort of vendor agreement in place, so you would have to wait until conflicting contracts expire to implement the new one. Performance measures. In order to measure the success, data would have to be evaluated. To properly track trends, a relationship would have to be established with the sustainability coordinator to track paper purchases. The reason we need to track by purchases and not by waste is because we are a public campus. Anyone can walk onto our campus and dispose of their waste. This is a limiting factor because we are measuring our success by one metric. Currently, there is data going back to 2015, which tracks paper purchases by CSUN. I have not incorporated the data in the slides due to privacy reasons. You can plot the current data to show you the trend over the last 5 years. If you document the date that the rules were implemented, you could then see about a year later if the changes had an impact on consumption. Other limiting factors concerning tracking success from purchasing data is the data itself. The distributor does not fully allow every field needed to track paper usage. In order to get the desired fields, a sample size was taken to infer some data points. Given there was an incredibly small sample size, there was a large margin for error mathematically, but the numbers seem to make logical sense. Closing thoughts. Throughout our talk, we have learned that every organization, starting from our very own all the way up to the global level, agree that carbon emissions are influencing global warming and are having a negative effect. At the university level, paper consumption is contributing to this issue. By limiting our own usage, we are reducing carbon dioxide levels, reducing landfill volume, and allowing our university to divert the cost of paper to a greener infrastructure.